So I'm Minja. I'm a robotics designer from Futurice. Just very briefly about Futurice. Probably everyone here has heard about Futurice, hopefully. No? Okay, so we're a digital innovation consultancy. We have offices all around Europe. We employ designers, business advisors, and developers. We have a few other interesting design projects. We have the IA design kit, which is an intelligence augmentation kit, and also an IoT service kit. So if you're interested in those things, I recommend you check those out. Then to designing social robots. So this is about hypothesis-driven development, and I'm going to tell you about how a robot helped children with autism learn sign language. This design case was creating an in-move robot to be adaptable to teach children with autism. We did this at Futurice in collaboration with Satakunta Healthcare District, so far away, and PrisTech. They were funding the project. Are you familiar with social robots, social robotics? A little bit? A working definition of social robotics, the one that I like to use, is that social robots are robots that have the primary task of interacting with people. So, for example, a robot in a factory that never interacts with a person is not a social robot. But, for example, a pepper that you might see in a store that's greeting you, that's already a social robot. Maybe not always a great one, but it's still one. Also, I like to think of social robots as having a physical entity. So software robots have kind of different design considerations, so I don't really want to go into that here. If at any point you have any questions, if I use any terms that are confusing, please just stop me and ask. So yes, the InMove robot, it's created by Gaël Langevin. He's a French sculptor, and he has made this open source. It's available online. You can print it at home if you want to. All the software is also available as open source online. It took us around 6 months to build this robot, so it's not an afternoon project, but you can still do it if you want to. We built an instance of InMove at Futurice, and we called it Momo, which was unfortunate when this scandal with children scaring bot happened, but that turned out to be fake, luckily. Are you familiar with what autism spectrum disorder is or what it entails? Some nods? I'll give you briefly a definition or give you some of the characteristics that are associated with autism spectrum disorder so you have a better understanding of who we're designing for here. So people with autism generally have problems in social interactions, in communication, and flexibility. So meeting new people could be very difficult. Meeting even people they know could be difficult. Some of them follow a very tight routine, so any lapses in the routine might cause some upset. These are thought to stem from a lack of theory of mind, which means that people know that other people also have thoughts and feelings. So the current theory is that people with autism have some lacking in this understanding. They also have trouble integrating information into a whole, so they might get fixated on a certain detail in their environment and focus on that and not really focus on what's happening around them, which leads to these social communication and flexibility problems. However, it's a spectrum, so not every autistic person is the same, not every autistic child is the same. These are kind of general things that you can see among the population. We defined these characteristics of people with autism, then we can define what they might need in a robot. Structure, safety, and modularity were things that we thought would be very important. Since people with autism have problems with flexibility, having structure is really important. Since we're dealing with children, they might get scared by the robot. They might get scared by the fact that when they're coming to interact with the robot, it's a new situation for them. which is why we need to create an element of safety. And we did this by having the child's parent with them at all times. The robot would also need to be modular, since children with autism have different needs, then the robot may need to adapt to those needs. Okay, but why build a robot for autistic children in the first place, and why sign language? This brief came from Satakunta Healthcare District. They had a psychologist and a speech therapist who worked with us, and they thought that this robot could potentially be easier to understand than humans. So 50% of autistic people are actually mute in adulthood. They communicate with other means. Sign language is the most used form of assistive communication by people with autism. They've also been found to have a special interest in technology and robotics. So previous methods of therapies with people with autism have found that when there's robotic components involved, they're more engaged. So both of these things kind of logically lead to maybe a robot could be easier to understand. How I approached this problem was, this was my master's thesis project, so of course I had to do some literature review. I looked at a lot of previous robots that have been used for children with autism, and we did the co-design with the psychologist and a speech therapist. So we have a pretty good purpose for building this robot. Probably we need to take a look at the ethics. Are you familiar with robot ethics? Have you seen some of the news that's been going on? A little bit. I'll give you a few examples why I explain these ethical guidelines that I created for social robots. So firstly, of course, we need to think about physical safety. If machines are operating autonomously, they need to take human safety into account. So people shouldn't get pinched or pushed or hurt by machinery. Well, we define that the child shouldn't touch the robot at all. We did this by the speech therapist being present with the child when they were interacting with the social robots. Safety of data. We just had a presentation on giving data to companies. So kind of building on that, we want to keep the child's data encrypted, especially in fields where robots are used in healthcare, childcare, elder care. These people are vulnerable. They don't always understand what their data is being used for. So it's important to keep it encrypted and, of course, not collect data that is not needed. Correct behavior enforcement. This is quite specific to robotics. It's been shown that people can actually transfer learned behaviors from technology to humans. So have you read any news about using the Alexa? Children have been using the Alexa at home, and actually they've been becoming more rude as a result. So because Alexa does not ask a child to say please and thank you, they forgot to say that to their parents or other children as well, which is why a robot should also enforce these social rules that we have, which we owe to each other. In this situation, since this was a prototype, we did this by having the therapist enforce correct behavior. So there was one child who really, really loved the robot. He was laughing throughout the whole experiment, but he also really, really wanted to hug the robot. So he was kind of going at it quite aggressively. And the therapist was there to calm him down, like, this is not okay, we need to behave. Equality across users. Probably you've heard about some of the racist or sexist algorithms that have been implemented, unfortunately. One really terrible example is an algorithm that was used in the US justice system to estimate recidivism rate. So to estimate how likely a person would commit a crime again after they've been convicted. And the algorithm was racist against black people because the data that was used to build the algorithm is racist. So when we build algorithms for robots, if they're dealing with this type of personal information, we need to take into account if the data is biased. Another thing actually specific to robots, male robots are often used in instances where the robot has to be powerful, And female robots are often used in instances of service jobs. So that's something to think about, I think. In this case, we wanted to make the robot gender neutral because we were having both autistic boys and girls coming over. So we thought with a therapist, we want them all to feel equally welcome. So we decided no gender for this robot. Robots don't even need gender, so it's kind of a weird question, I think. Transparency. This means that people should understand why the robot is doing what it's doing. The person should somehow be able to check if the robot is behaving correctly so they know how to calibrate their level of trust to the robot. In our case, we told the parents and the children that the robot was teleoperated at the end. So teleoperated means it was remote controlled by a human. We wanted to do this because we didn't want them to get any false expectations of what technology can do at this time. The therapy of autism is very difficult to begin with. We don't want to give any false hope. Even though technology is evolving, it's not there yet. Emotional consideration. This is also quite specific to robotics. So it's been shown that people actually create emotional attachments to robots. Even though people know that they're not alive, we still treat them as if they were, especially if the robots have a name or a backstory. In this case, we wanted the child to know that the therapist was not being replaced. That's why the therapist was also in the room the whole time. And even if this robot were to be implemented further from this prototype, were to be taken into use in healthcare, we would still not replace the therapist. So the robot would be there to support the therapist's job. So that was our whole hypothetical design that we created. And after this, we, of course, went to perform some experiments. So how were these set up? We had 3 different design conditions. So the robot was speaking and signing. It was speaking, signing, and showing a picture of the object that it's signing. And thirdly, it was speaking and signing and flashing some lights. So we wanted to see if a combination of communication methods, so if using the hands and an image is better than these other methods. We had 10 children come over. They learned 9 signs, or they were asked to imitate 9 signs. The experiments were from 6 to 28 minutes. This kind of illustrates how much of a spectrum it is. Some children signed all the signs correctly right away. Some of them did not sign correctly at all, so it really depends. Present in the experimentation room were the child, their companion, so their parent or other loved one, and a speech therapist. We measured the child's eye gaze and imitation success. So this was quite a scientific approach to measuring how well the robot is doing. We also did a survey with the child and their companion. And like I said earlier, the robot was teleoperated from the next room. So here we have a video of the robot in operation. So now it's signing duck. These were 9 signs that are kind of taught to children anyway, so they're part of children's vocabulary. This robot was built quite quickly. We were still 3D printing some parts for it the previous evening in our hotel room. You can see that the screen is flashing. That's because it's pinging a server every few seconds to ask what image it should be showing. So it's not the most beautiful software package, but it's a prototype. And we wanted to illustrate that we can do this type of socially impactful prototyping quite quickly. So what was the outcome? Unfortunately, I have an external link. I don't know if I can show that or not. Yeah. Let's hope that there's no sensitive information in here. Oh, internet. What was the password? Which one is it? Which internet is it? Oh, okay. And mikä? Kaukkula? Paukkulanka. Paukkulanka Kera. Okay. Let's see. Oh, here we go. Sorry about that. Where is it? Is it coming over? Oh, yes. Here we are. The speech therapist is showing the camera at the back of the room that it was incorrect. And then we're operating the robot accordingly. Now she's showing that it's correct. I love how she's so exactly copying the robot. Now I've lost my cursor. Here we are. Yes, great. So the results of the experiment, 7 out of 10 children imitated the robot. The girl you saw there, Maisa, she was one of the best ones, so she signed everything correctly. Image was the best design conditions, according to the children's companions. So by image, I mean that the robot was showing the picture on the tablet at the same time. The children said that it was mainly a positive experience, although sometimes the robot was a little bit scary. So it's a human-sized torso. It's bigger than me. It's like an adult man-sized. So I think maybe that should be made a little bit cuter for children in the future. All of the companions said that they thought that the children had a connection with the robot. And most of them said that the robot could be beneficial in the future. Of course, this would need more development. And we need to verify whether our children understand the signs and whether they're capable of learning the signs from the robot, because now we only verified that the children copied the signs from the robot. So long-term learning is, of course, measured differently. Like I said earlier, we wanted to show that rapid prototyping of high-end tech is possible with people who really need it the most. I'll quickly share the method that I developed during my master's thesis for designing social robots. This is kind of optimized for these consultancy environments or environments where a multidisciplinary team is working to create something quickly, working to create a prototype quickly. We use this in the autism case, but we also have used this with Yle and Audi to build some social robots for them. It's quite basic kind of design stuff. Firstly, you define the problem space. Based on what the problem is like, you make some design guidelines, which you then follow when you define the solution. And I think the solution of a robot has 4 components: the environment or the context it's operating in, its form, so how it looks, how it sounds, how it interacts, and then how it behaves. If you want to try it out, you can achieve these benefits of co-designing with users and experts, putting in the ethical considerations, which we discussed earlier, and having a structured process with explicit design decisions. There are some canvases online, which you can take a look at. There's 8 in total. You don't have to do them all. You can take a few or just take one or do all if you're very excited about it. First, you do the problem space canvas. This is the method we followed with Yle and Audi. First, you do the problem space canvas, then you do the ethical considerations, then you make design guidelines, and then you build an MVP. If you want to go more in depth into the design of the robot itself, you don't have to do this MVP. There's 4 different canvases which go into the 4 dimensions, so environment, form, behavior, interaction. this is what it looks like to design a robot. This is from our workshop with Audi. So we have canvases, we have post-its, very, very basic design stuff. The end result is just a bit different. Thank you. And here's the link to the canvases if you want to see them. If you have some questions and you don't want to ask me now, you can ask me later on Twitter. Of course, go to Futurice website. Yay.
Wow, amazing topic, also really interesting project for sure. Anyone wants to ask something?
Yeah, thank you for the great presentation. I have a question concerning your hypothesis, with a social robot. Do I understand it right that what you think about it, that you assume that the social robot will create the kind of emotional connection to the users in comparison, because I don't see, for instance, a screen or animated figure doing the same. How does it, was your hypothesis that this would be more efficient somehow than having just, learning with a screen or an animated character?
Well, there's a lot of previous research on that, so I specifically did not examine that here. But it's been shown that if a character has its own physical form as compared to a screen, it's more compelling. So I think it's a combination of its physical presence, so it's actually there with you in the room. You can see it from all angles. It's moving by itself, so that already kind of ascribes some kind of intentionality to it. So people perceive it as if it were alive, even though it's not. Yeah.
Hi, so thanks. I think, so one question, so the control, where was the control? And if you would choose a control, what would it be? Would it be, like you said, like an animation, or would the best control be a real human?
So in this case, the control was the 3 different design conditions. So speaking and signing and showing the image, and then speaking and signing and showing this lights. So we were only comparing these things to each other. We were not comparing to a human. So this was not a clinical study. This was kind of verifying a prototype. And our hypotheses were, the children are going to sign, which was correct. And then we had some other hypotheses, was that we compared in the survey the opinions of the parents, like, do you think the connection to the robot happened? And they said that it happened. But of course, like, if this were to be developed into a medical clinical product, yes, definitely we would need a control study with a human. We would need long-term studies. This was only one instance. But unfortunately, this study was only so big and we could only do so much. Yeah.
But if you could pick one, so basically put the robot one, and then you'd have a person, maybe a video, like, would that be a good control?
I think the use case of this robot is to use it within therapy in conjunction with the therapist. So we wouldn't really need to compare that with a human. It would just be either a therapist and the robot, or then only the therapist, and see whether that has some effects. And some of the other effects that we noted is that it's not only beneficial for the children, potentially, it's also potentially beneficial for the therapist. So if the therapist has the robot there, their cognitive load is a little bit reduced, and then maybe they can have a longer therapy session. Because generally speech therapy sessions are like 45 minutes, because it's quite challenging. How I was just viewing from the other room, but even I was a little bit exhausted after looking at those sessions, because there's a lot to do there. If the robot was there, maybe the therapist could have the robot do some of the signing, and then the therapist could spend more time maybe planning the session and doing the robot or controlling the robot there, this type of thing. So, but yeah, further research is needed, as is always said in science.
I think you sort of like answered part of my question at least, but just like ethical considerations, which you had some of the, but why replace a human with a robot, or why use a robot in conjunction with a human as opposed to just a human? What's the like the ethical basis for that?
Yeah, I wouldn't replace a human here at all. Sorry, but I think the robot would be useful because the previous research has proven that using a robot in therapy kind of makes the autistic person more engaged in the therapy. So
As opposed to just the person.
yeah, as
Okay.
opposed to like other methods. Yeah.